Let's look at another example to show how this works, and specifically how it works in concert with inductive reasoning. So let's start with a number. Let's select any number we want. Then add 3 to that number. Double whatever you get from that. Add 4. Divide what you got from there by 2. And then subtract the number that you started with. What we want to do is figure out where this pattern goes, what it does generally. So we want to figure this idea out. First, we're going to do is use inductive reasoning. We're going to think about what might happen generally by looking at some specific cases, by throwing in some specific numbers and seeing what happens. So let's take a specific number, and I'll denote our specific number with n. Let's say, look at n equals 1. So remember what our pattern is. We take this value, n equals 1. So we have 1, then add 3, get 4. Then at the next step, you double that. So 2 times 4 would give us 8. Then we add 4 to this. Get 8 plus 4 equals 12. Then with that value, we divide this by 2. To throw the whole thing over 2. 12 over 2 gives us 6. And then we subtract the original value. We'll call that original value n, where here we said n is equal to 1. It's 6 minus 1 equals 5. So what this tells us is following the steps outlined by our pattern, plugging in 1 gives back 5. Okay, that's a good start. Let's try another number. Let's try 3. Doesn't really matter what we try, right? We're just going to pick some numbers. Let's let n equal 3. So we start 3 plus 3 is equal to 6. Then we take that, multiply it by 2. 2 times 6 is equal to 12. Add 4. And we get 12 plus 4 equals 16. Then divide by 2. And you get 16 over 2 equals 8. And finally, subtract the original value, which here, remember, made 3. 8 minus 3 is equal to 5. Okay, got 2 values. Let's say when we plug a number in, we get back 5. Like I said, 2 is not really enough. Let's pick another one. We'll pick one at random, but not that random. We'll make it kind of fun. Let's see what happens if we plug 5 in. Say n equals 5. So we start by adding 3. You get 8. Then you multiply by 2. 2 times 8 gives 16. Add 4. 16 plus 4 gives us 20. Divide by 2. 20 over 2 equals 10. And subtract n means subtracting 5. 10 minus 5 is equal 5. So as you can see here, plugged in 3 cases. We got all 5 in 3 cases. So it smells like, from induction, our pattern is a bunch of 5s. That's our conjecture here. The pattern is 5s. Did I get that question mark there? Because we're not quite sure if that pattern has to be 5s. Other things might happen here, right? Okay? But let's just keep that idea in mind, that we're thinking our pattern is a whole bunch of 5s. And now that we've tried induction to give us an idea, let's use deduction to prove our idea. Now our goal in this case is to prove that if we plug in any number, we'll always get 5 back. If you want to prove something happens for any number, you need to plug in a general placeholder. You say, okay, I'll give you anything. You've got to give me back what I want. We'll just plug in n. N is the general placeholder when we want to plug in any natural number value. A natural number, I'll talk about that a bit more later, is the counting numbers 1, 2, 3, 4, 5, and so on. Let's just plug in n. N plus 3, that does nothing. We get n plus 3. We're plugging in any n. We don't really know what happens yet. Multiply it by 2. 2 times n plus 3. Remember to distribute these values. You get 2n plus 6. Add 4. 2n plus 6 plus 4. You get 2n plus 10. Divide by 2. 2n plus 10 over 2. Remember, you gotta distribute again. Get an n on the first and a 5 at the second, and it looks like we're actually where we want to be. Remember, last step is subtracting n. For here, we started with general n. So we're going to have n plus 5 minus n, which would just leave us with 5. So, pattern is 5. We found that out by using induction to give us our idea, and deduction to more officially show it. I will say that in general with this type of problem, it's the sort of thing that comes with a lot of practice. I was able to do it pretty easily because I had a lot of practice with this type of thing and also because I knew where I was going. So don't get discouraged if it takes a little while for this stuff to click. It's not obvious. It's the sort of thing that will come with practice. You just got to give it your time.